In this video, we're going to explore bounds and uh, add in some higher level challenge to this because we've done a previous video and topic on bounds and error intervals. So just as a very quick recap, we might have something like E equals 14.5 to 1 decimal place, and you're expected to do the error intervals or the bounds, the upper bound 14.55 and 14.45 for the lower bound. So you need that knowledge first before you attempt these questions. So if this isn't solid, like you can't look at this and just stick the 5 on the end and subtract the same amount, then go back and practice that before attempting these calculations, because what they're going to do next is have another letter, let's say 21 to the nearest integer, and we're going to do the same thing, 21.5 and 20.5 for the upper and lower bounds, and then we need to start doing some calculations. Okay, so let's have a look at an example of a calculation you might see with this. It could be like in a picture form, or it could just be in a written form, something like C equals EF. Okay, I might make the C just an A to highlight this a little bit better, actually. So capital A equals E times F. And we want to know the upper bound of A. I'm just going to do A with a little arrow pointing upwards for upper bound of A. So E times F multiplied together. Okay, so we're doing E times F to try and get the biggest possible A in this case. A is E times F, but we want the biggest possible A that we can get. So we take the upper bound of E, 14.55, and times it by the upper bound of F, 21.5. Okay, and you might say, well, yeah, you can't actually have these numbers, but our upper bound would be a less than kind of idea. Okay, don't worry about the intricacies of this too much. We just take the two upper bounds and multiply them together to get the biggest A possible. And if they wanted the minimum or the lower bound of A, we would multiply the two smallest ones together. Most students are absolutely fine with timesing two numbers together and choosing the two highest and the two smallest because it kind of makes sense. And if you're ever in doubt, these will be in calculator papers. Actually do the calculations. Do these two multiplied, do the two smallest multiplied. You can even do the other two combinations if you want. Just to show to yourself that this is the highest possible combination. That would be your check. In terms of a picture like this, then you might be thinking of terms of E and F like this. And so E at its lower bound might be sort of this length, and its upper bound this length. So E can be anything between here and here, if that makes sense. Okay, that's the smallest length it can be and the biggest. So 14.5 normally, but that would be 14.5 the blue line, and then 14.45, 14.55 at the upper bound. If I do the same for F, then the smallest it might be would be something like this, and then the biggest would be something like this. So when we're looking at A, I chose capital A for the area. The smallest possible area would be this purple and red line here, which would kind of take us to there. That would be our smallest possible area. Okay, the two smallest multiplied together. And for the largest, it would be the widest E and the longest F, and that would add this extra kind of area on here that we didn't have before. Okay, so this is the concept when we're multiplying these two things together. Okay, if you were adding as well, E plus F, you would add the two largest ones together. But my advice to you is go with your instinct at first, and then just when you're coming back to check your answers, try a few different combinations just to clarify to yourself that you've actually picked the right ones. Because the last part of this is doing a division, okay? E divided by F as an example. And this one confuses students because when we're dividing, we don't want to divide the biggest by the biggest. That's not the biggest A that we can possibly have. So the pattern is the numerator and this one here. If I want the largest possible area, or A, just A, then I would take the largest E and divide by the smallest F. So these two match, and this one on the bottom is the opposite. If I wanted to have the lowest possible A, I would take the smallest E and divide it by the largest F. And the only way I can kind of contextualize this for students when I teach this is to think of sharing a pizza. Okay, the E, the numerator, is the size of the pizza, and the denominator is the number of people. So if you want the largest amount of pizza, you would buy the biggest pizza you can get, and you try to share it with as few people as possible. You know, only share it with 1 or 2 people, you're going to get a lot of pizza. But if you make the denominator large, you're sharing that pizza with more people, you will get less. If you don't want very much pizza, you buy a small one and you share it with lots of people. So this concept with the division is the confusing part. I think with the multiplying, students are usually fine with this, but with the division, it trips students up. Okay, so the pattern is the numerator and this one match, and the denominator is the opposite. Like I say, you can always check by doing the 4 combinations: max divided by max, max min, min min, and min max. There's 4 combinations you can possibly have, and then you will know in the exam